Welcome to the Explainer. Today, we're digging into a feature that is about to fundamentally change one of the most powerful programming languages on the planet. I'm talking about C++. Okay, so let's just dive right into this, because it sounds like something straight out of science fiction, right? But this idea, code that can actually understand and even generate itself, well, it's not sci-fi anymore. It's becoming a reality in C++. And this absolutely revolutionary new capability, it's called static reflection. So here's the crucial part, the thing you really need to get. All of this happens at compile time. That means it's happening before the program even runs. And because of that, it's incredibly fast and efficient. It's a huge leg up on the kind of slower runtime reflection you might see in other languages. I mean, this quote just says it all, doesn't it? It really highlights how big of a deal this is. We're talking about the very first version, and it's already being called best in class. That's not just an update, that's a massive leap forward. Okay, to really get why this is such a game changer, you have to look at how things used to be. For years, C++ developers were stuck using this incredibly complex workaround called template metaprogramming. Seriously, it was a nightmare. The code was obscure, debugging it was practically impossible, and it was just brutally slow to compile. Now, with reflection, the new way just reads like normal code. You can use your standard debuggers, and the compile speed, we're talking orders of magnitude faster. It's a night and day difference. All right, so what can you actually do with code that understands itself? Well, for starters, you can automate all the boring, tedious stuff that programmers hate doing. So let's take something like parsing data, reading a file. The old way, you had to manually write tons and tons of code just to define a data structure that matched that file. It was awful. With reflection, you just point it at the file. That's it. It looks at the structure and bam, it automatically generates a perfect, type-safe C++ structure to match. This saves hours of work and, you bet, prevents a ton of bugs. And we're not talking about small savings here. The scale of this automation is just incredible. Think about this. One developer took a task that used to need over 200 lines of really complex handwritten boilerplate code and replaced it with a single reusable function, a function that can now automatically generate what's needed for any data type, forever. That's a huge deal. And this really is the key takeaway. It's like a new motto for C++ developers. If you can write the code by hand, you can now write code to generate it. Any pattern, any tedious task you can think of, reflection can probably automate it for you. But listen, this goes way beyond just making life easier for programmers. It's not just about convenience. This is unlocking capabilities that are absolutely crucial for modern science and technology. Okay, one of the most powerful examples of this is something called automatic differentiation, or autodiff for short. And you should really think of this like a superpower for your code. It's a technique that lets a program automatically and perfectly calculate its own mathematical derivative, its rate of change. So, why should you care about this? Well, because that whole process, calculating derivatives, it's the mathematical engine that drives so much of our modern world. It's how we train AI. It's behind advanced scientific simulations and complex financial models. And with reflection, the program can literally inspect its own math and automatically generate the code to do this. We're talking about a task that used to take experts months of painstaking, error-prone work, and now it's automatic. Okay, so we've seen how reflection is a game changer inside C++. But its biggest impact, it might actually be on how all programming languages work together. Think about it. You've got Python, Rust, Java, all these different languages. When they need to talk to each other, when different systems need to communicate, what's that one universal language that connects all of them? Well, for better or for worse, the answer is the C programming language. Yeah, our entire digital world is pretty much built on its low-level and often unsafe foundation. But here's the problem. C is decades old. It doesn't have modern safety features, which makes it the source of countless, and I mean countless, security holes. If you look at history, great empires and ecosystems, think the Roman Empire and Latin, they're built on a powerful, common language, a lingua franca. C is kind of the lingua franca of our digital world. But with reflection, C++ now has the power to automatically generate these safe, high-level bridges to connect with other languages. It has a real shot at becoming a much safer, much more powerful successor to C. So I want to be really clear about this. This isn't just another feature. It's not an incremental update. This is a fundamental shift in what the language itself is even capable of. Probably the best way to think about it is like the invention of the jet engine. A jet engine wasn't just a better propeller plane, right? It was a total quantum leap. It created a whole new era of aviation. And that's what reflection is for C++. It's that jet engine moment. It unlocks a whole new world of possibilities. I mean, think about it. The first commercial jets, like the Boeing 707, they immediately offered double the speed, double the passenger capacity. They basically made the old propeller technology obsolete almost overnight. That's the kind of jump we're talking about. And this feeling is really captured perfectly by this quote. There's this story where a key member of the C++ Standards Committee was told that reflection was officially on track to be included. And her response, totally deadpan and understated, was just, whole new language. That says it all. It feels like they've been given an entirely new tool to work with. And that's really what's happened here. A tool that our entire digital world is built on just got its jet engine. So the real question is, what becomes possible when one of our most essential tools becomes a quantum leap smarter? Well, reflection has arrived. The frontier is wide open. And for the next decade, I think we're all about to find out. Thanks for watching.